So let's start with the second chapter from this fantastic book by Gelfand and Saul. I hope you enjoyed working with the examples of chapter 0. So this is now chapter 1 and the page numbers are 21 to 39, and once again I recommend all examples and exercises. So let's go through some interesting things that Gelfand has talked about in this chapter. The first thing that comes to my mind is given a acute angle, if you are given the values of the any of the trigonometric angles ratios, let's say you have a sine of gamma, and if the value is given, let's say it's 12 by 13, then it is very easy to find the values of all other trigonometric ratios, let's say cos, tan and cosec, it doesn't matter, sec, cot. So how does one go about finding all the values of this acute angle gamma? So you please draw a triangle and put this information on the triangle. The ratio of sine gamma, that is opposite side, upon the hypotenuse has been given as 12 by 13. Then you use the Pythagoras theorem, in this case 13 square minus 12 square and then square root, and you get this to be 5, and you can immediately write then cos gamma is equal to 5 by 13, and tan gamma is equal to opposite side upon adjacent side, 12 by 5. So all the values are staring at you by simply drawing this triangle. And I think this, in spite of its simplicity, is the most useful thing that I've learned in trigonometry. Then the next thing he talks about in this chapter is one of the most beautiful theorems of the angles of a triangle. Now in this particular example, he takes the triangle to be acute, and he proves this theorem and promises to prove the theorem even when the triangle is not an acute triangle in later chapters. Now the theorem is can be written down like this: A, which is this side of the triangle, divided by sine of A, which is A being